All right, so this basically demonstrates this arrangement of things. Now, so I told you that when you have the return type, function name, and a set of input parameters, and something that looks like executable code inside, and the opening curly brace and the closing curly brace represents the body of the function. And when you have a definition like this, we say it's a function definition. Function definition means that it's fully defined. Compiler knows absolutely everything about this function, what it does, what kind of input parameters it expects, and what kind of result it generates. So let me try to kind of demonstrate that. For example, if I forgot to pass in the value to function name square, just like I forgot that it needs an input parameter, right? If I want to build it, it gives me an error, and when we use code blocks, it will be very similar. Typically, you find the first place where your output says error, and double click on it, and it'll take you to the line of code which compiler feels is offending the rule or something, right? And so my output here says function square does not take 0 arguments. That makes sense. Normally in the error messages, when you forgot an actual parameter right here, it refers to them as actual arguments or simply arguments. Okay, arguments, parameters, these are interchangeable kind of terms. I would say that I would disambiguate it is that you can see that it takes an argument to pass to this function for this code to even compile, and then of course hopefully properly execute. So I would often refer to this as actual parameter, the actual parameter that we use to say, hey, square, take this value from us, use it inside, x assumes that value, do your computation, and then compute this result and pass it over to the result, and we can continue on with our program inside our main function. Okay, so anyway, so this is the actual argument or parameter, and this would be called a formal parameter, right? This is a formal parameter because the next time I can call a square again, and the next time I can pass something like 1, 2, 3, 4, 5 instead of the value, and the next time I can call it and say 1, 2, 3, 4, 5 plus value, right? I can compute the actual arguments on the fly, right? Whatever the needs are, I can compute what I want to use as an input parameter for square using expressions, using variables, using hard-coded numbers like that. But every time I make this call, okay, x will assume whatever is the result of this. So let me explain again. When you see something like this, what happens here? Again, let's try to demonstrate this very quickly. Let me resize this again so that it all stays readable. Okay, so this is our program. So let's take a look at, say, this part, okay, and say, what's going on? How can we talk about what's going on in this portion? So obviously, before square, which is, let me actually switch the size of this so that I can see my marker better, okay? Before we can make a call to square from this place, we need to compute this thing, this expression, right? This is the expression, which is 1, 2, 3, 4, 5, 12,345, plus whatever the value is, okay? And so, of course, when CPU executes our program, it will see this expression, it will pick the value, 1200, 12,000, whatever, plus the value. It will pick the value. It will do the computation like plus, and it will store the result in a temporary variable, right? Like temporary value directly stored inside the CPU. That's what normally happens. What happens next that we know that the square, let me now switch to a finer print. We know that what we have is this, memory that we have, and main function already has its stack frame right here. This is the stack part. Stack is where all local variables defined inside of our functions live. We talked about this last week, right? So we have value. Which is part of what main knows about its local variables, and we have this result, which we will be populating when the square returns. Every time square returns, we populate result with the new value. All right. So what happens is that the main gets its stack frame, right? So this portion of memory is called stack frame, and stack frame is pretty much the housing for local variables. We can say local variables of main function. Okay, we don't create main function. We don't tell anyone to call this function. Whenever we execute our program, main function is invoked for us, right, by the operating system loader, and then as soon as the program begins to execute. But this is our first attempt to make a function called square, right? So every time square is about to be invoked, the argument, and I'll switch back to this line of code. The argument, we already computed it, and the argument for this function is going to be copied on the stack. Okay, so this is let's see that for the sake of the argument, the value is 5. So this value is 12. This value here, temporary value, is 12,350, okay? And so this value, 12,350, which is decimal value, is copied on the stack. Then we go ahead, and every time we make a call into function named square, what needs to happen before it begins to execute, it creates its own stack frame, right? So this is another stack frame, this time for square, for a function named square. Before the call to square was made, the temporary value 12,350 was already copied into this memory area before its stack frame was built. But magically, this input parameter will be configured in such a way that this x will be, let me just redo this, this x will be pointing directly to this memory location, and this is how square gets its initial value. Through this function call mechanism, that the function parameter is copied into the stack, and when the stack frame is assembled for function square, it finds that its x variable right here will be having this value, right? So this is like a variable which actually is a local variable to square, but initialized before square was invoked. And then, of course, it'll do its computation, right? It'll do 12,000 times 12,000. And it will compute, so it will compute x times x. And the result of this computation, again, is stored somewhere in the temporary memory location directly inside the CPU. Then when we return, this memory, as soon as this function returns, we have this return statement which returns the value. This memory is erased, okay? All of it's gone. All of this is gone, okay, just like this. And we're now back to main function, so we get our result. And of course, it's the CPU knows that part of the function return mechanism, part of this calling the function, is to make sure that we store the result in the result variable, and of course this result variable will get its result directly. Essentially, what I was showing you here is that I should probably show that this result is returned back to the stack frame of main, and this is where result is pointing to, right? The result is this specific location, because this is a stack frame for main. Now, as I'm talking about this function call and return mechanism, I keep looking at this, and when I say integer result, try to make a square function call, passing specific value, right? Then return. Then I say again integer result. This is called variable redefinition, and this is not allowed, okay? For instance, if I say build, it says redefinition, multiple initialization, and blah, blah, blah. What I need to do is that I cannot redeclare the variable in the same scope. I need to simply start using it. And start using it is that I can use my result, but I cannot redeclare it. I need to declare my variable only once. So only once I tell the compiler, I would like to have a variable name result, and I want this to be an integer, okay? The next time I want to use it, I do not declare it. I just say, hey, see, I already have this variable result. Could you please return the value from the square call back to the result and store it there for me? Okay, so this covers for us, this very informal introduction to function call and return mechanism. And so far, what I want you to remember, so this time it should all work, right? But I want you to remember is that what we're looking at is we're trying to talk about functions. So functions have names. Functions have input parameters. Functions have return values. Return statement allows you to provide the return value. You already know that this return statement essentially gives it to the CPU to temporarily hold. And when the control returns back to function main, the CPU will be populating the result variable with whatever was computed here in the duration of the square call.